Now, let us move on to the concept of energy. It is important to realize that energy and work are related to one another. When work is done to an object, energy is transferred to that object. This allows it to also do work on another object. For example, an archer does work on the bowstring by pulling it. Once released, the bowstring will do work on the arrow, propelling it forward. A heavy mass can be pulled upward using a pulley, and once dropped, it can drive a wooden spike to the ground. This is a simplified version of a mechanical pile driver, commonly seen on construction sites of bridges. A pile driver is a heavy duty machine that can implant piles or tubes deep into the ground. The bowstring and the elevated ram or mass have mechanical energy, which allow them to do work on another object. Mechanical energy can exist in two forms: potential and kinetic energy. Going back to the bowstring example, energy is transferred when the archer pulled against the string. This mechanical energy exists in the form of elastic potential energy. The same energy is present when we use a slingshot. Another form of potential energy is the chemical potential energy stored in food. Once eaten, the stored energy gets broken down by the body into useful forms, which enables us to do work on other objects. Batteries also have stored electrical potential energy that can do work in this simple circuit. However, in this topic, we are most interested on the third type of potential energy, the gravitational potential energy. Gravitational potential energy, or PE, is the stored energy possessed by elevated objects, as in the ram and pile driver example. Gravitational potential energy depends on two variables: the weight of the object and the height of the object from a 0 point position. Since the weight of an object is calculated by multiplying the mass of the object by g, or 9.8 meter per second squared, if we are on the surface of the earth, the formula for PE is equal to m times g times h. It is also important to understand what height we are referring to. Usually, this can be taken as the ground or the floor. In this illustration, let us set the landing of the stairs as the zero height position. This means that if we place a ball on there, it would have zero potential energy, since it is not raised above the reference point. However, if we assume that raising the ball one step above would also increase the potential energy by 5 joules, then it goes to say that at the top of the stairs, the ball's potential energy would be 20 joules. Remember that choosing the zero height position is arbitrary. If we instead choose the first step as our reference height, then the potential energy will adjust correspondingly.